guys. Just so you know.
She's gonna pour the boiling hot water into the ice cold water.
I don't want to play.
This is going up on my channel.
I know.
We all ready? Can you see, Jesse?
Yep, I'm
You
out.
can see this? Okay, here we go. Watch what happens.
Whoa!
So what did the can do?
It
It
collapsed.
collapsed. Yeah, why did the can collapse?
Because it was on hot and then it went to.
Because it had
Okay,
an
so
immediate pressure difference.
hold on. We'll get to, so it was on hot. All the particles were all spread out, moving around. When I flipped it upside down, why did I flip it upside down?
So all the hot water come out.
No.
Oh.
Why did I flip it upside down?
So it
So-
wouldn't come out.
To block the hole, so nothing could go in and nothing
And
could
then
come
all
out.
that pressure.
Okay, so essentially the hole's blocked. Nothing's leaving the can, nothing's going in the can. But what do the particles do when I flip it upside down?
They touch it.
Because
Gravity pulls it down and cold water hits the hot water.
so what do the particles do? This water in here is cold, obviously, that's why there's ice in
Oh,
it.
they stop. They
So the particles stop. They stop moving all around. So what happens to the space they take up? They take up less space. Can we have an area of empty space inside of this can?
No.
No, we can't have an area of emptiness. Something has to fill it in.
No matter what, you can never have emptiness unless it's a vacuum.
Yeah. So if I would have put this in like this, what would have gone to fill that emptiness?
Nothing.
Air. And it would have gone in how? Through the top. But because I closed that, the air still wanted to fill it, but could it get into the can?
Nope.
No, so what did it do?
Crush the can.
It crushed the can.
I want to do that.
I have a
Okay,
project that-
so hold on. So the cool thing is, we crushed this can without even touching it, right? I purposely made sure that these let go quickly so that you could see that it was actually the can that did it. We crushed this can with air alone. This air outside of here,
I
this
saw
pressure,
a video.
this pressure out here was enough to crush this can. Do you feel pressure right now? Like when we're standing here, do we feel stuff pushing on us? No.
But there is.
There is air pushing us. Why don't we feel it?
Because it's so low.
No,
Well, our senses aren't good enough.
no,
Because our like atoms and stuff are better than theirs.
no.
No?
It all has to do with what you're used to. So what does that mean?
We're used to the pressure around us
We're used to the pressure around us. So
with particles.
where can we go that we notice that there's a pressure difference?
Mountain.
In the mountain. What happens when you're driving in your car with your parents and you go up the mountain?
Your ears might pop.
Your ears might pop.
Might.
Because the pressure up there is less.
My ears don't
So
like
what
popping.
happens is, when you go up the mountain, you have more pressure inside of your head, more pressure inside of your head, and your head's like, we got lots of pressure up. So your
Then
ears
you
pop
Go in the pool and
to
swim
just,
down.
hold on.
Yeah.
We'll come to that. Your ears pop to let some of the pressure out
Not all
so
of
that you can be stabilized.
Not all
Okay?
people do.
Same thing in a plane. In a pool, it's the opposite. In a pool, you go down, and what happens to the pressure?
It gets bigger.
It gets bigger. There's more pressure. And so you have less pressure in your head, so what happens is you feel like your ears are being squished in. And sometimes your ears will pop to let some pressure in so that your ears can be stabilized. Usually we don't want that to happen. What do people do when they go really deep into the water?
They
Well,
crush. They get crushed.
But what do they do? Well, yes. If they went all the way down to the bottom of the ocean, they would crush. What do they do when they go like,
Scuba diving.
yes, what do they do?
Scuba gear.
Scuba gear. And the purpose of the scuba gear is to make sure that the pressure's the same. Okay, make sure they can breathe oxygen too, but make sure the pressure's the same so that they don't have anything that pushes in on them. So here's a question for you, and this relates to what we were just talking about. How do fish tell us that there's pressure down in the water?
Bubbles.
No? Let me ask it in a different way. When you go fishing, okay, how many people have gone fishing and caught a fish? And you catch your fish, and your parents want a picture of you with your fish, right? They want a picture of you holding your first fish so they can show it to everybody, and you're holding your first fish.
Because they can't breathe.
Nope, doesn't have to do with their breathing. But something happens to the fish when you're holding it that you can see, that shows you that there's pressure under the water, and it's more than what the pressure is up here in the air.
Their gills
What
open up.
happens to the fish?
The
Not their gills.
scales.
What
Mouth.
happens? What changes about the look of the fish?
The eyes.
What about them?
They dilate. Or,
They enhance.
They bulge out,
Yeah.
right? Eyes bulge out. Do you all know what I'm talking about?
yeah.
If you hold the fish up, the eyes start bulging out. Why?
Because there's all that pressure.
Because all the air is like, it's like a vacuum.
No, well, it's not really like a vacuum, but is there as much pressure in the air as there was in the water?
No.
No.
It's
So
just
they're
like-
used to the pressure in the water holding their eyeballs in at the right spot, and then when they come up here at the air and there's less pressure, their eyeballs pop out more. It's the soft tissue of them that pops out more. They don't have like the ears that we do to fix the pressure. Okay, their eyeballs are really their soft tissue, and that's what's going to bulge out. When you put them back in the water, are their eyes still bulged out?
Yeah, a little bit. Somewhat.
Right, when you put them back in, but then what happens?
They go back
They
down.
go back in because their body gets reused to the pressure.
If you put
Okay?
them back in.
Same thing that happens like if somebody gets hurt in their scuba gear, right? So somebody is down in the scuba diving and a shark gets their scuba gear and the pressure gets into the tank and they're not getting all that oxygen and everything, they're probably going to die.
Or like,
Because they're going to become they're going to come out and they're going to be really, really sick, and they have to go into a pressure chamber to get their body used to the pressure. When people go scuba diving, and I don't go scuba diving, but I know this from friends, you can't just go down to the bottom of the ocean. Well, you can't anyway, but you can't just go down like 300 feet. You have to go down slowly, and you have to let your gear and your body stabilize at certain things. Same thing when you come up. They can't just be like, oh, I have 2 minutes of air left, let me come up, and go all the way up. They have to know how long it's going to take at each of these stages and have enough air left so that they can come up slowly at the different stages. Even if somebody on the surface were to pull them totally up really fast and pull them out, they would probably die. Or they have to go in this pressure tank to get their body to pressurize and to restabilize correctly and slowly.
or like outer space.
Outer space is
If
the
you
same
go
way.
there, like,
Yeah,
like you get like something type of thing in your suit, it's like
yeah.
you're dead. It's
And
like,
one thing, let me show you something else that I was just thinking of that I have on my computer.
How much pressure there is.
it's a space bag.
On my computer, I have this cool picture. Anyone know what this picture is? Can you see it?
A mannequin head.
Picasso.
Picasso.
What is this picture? They are kind of mannequin heads. They're styrofoam.
They're those face things, like
Here's a fake one.
Face
Here's
off.
another one. Anyone
neck
know what it's
models.
from? What?
Neck models, or
No, they're styrofoam heads. I just said that.
oh, like I thought. You know,
This is
like
a normal one.
Is it from?
Nope. This is a, well, that's what they'd be used
And the other
for,
one is when they got
not-
put under extreme pressure.
This is a normal one that's up here on the earth. This is one that went in a submarine. What
See
happened
if
to it?
It went down too far enough, so
And what happened to it?
pressure.
And it's
Yeah,
like,
all the
it's
pressure
like neck
smushed it in.
broke.
Well, no, but all the pressure smushed in. See how much smaller it is? They were the exact same size. One went down in the submarine, one didn't. So one got totally smushed in from all that pressure. Just like you guys, if you went down there, your eyeballs would get all smushed in and all your soft tissue and everything. So we don't do that.
Yeah, I saw a thing though with that, but it was like bigger scale size. Like they took a crane and like a keg, like a 20-gallon keg,
Yes, they do it in like 5-gallon drums and stuff like that on YouTube
and
too.
they put it in like a pool full of ice,
Yeah.
and it's actually
And it,
it
yeah,
takes a little longer, but it's
but
like
it does the same cool thing. Yeah. All right. So
I should-
yes, Anthony.
There's this project that I did in my other school. Like you took a vase and a water balloon, and you tried to see if you could put the water balloon in the vase, but the balloon was bigger than the hole you had to put it in, and so we had to try to figure out how to put it in there.
Kind of like when you put an egg in. You can make an egg go in a little hole. A big egg.
Can
A
you?
little hole. Yeah.
They don't have
You
to.
can do that. All right. Let's focus on this first because you need to take a quiz.
I want to do
No, what are you doing?
I was recording.
Okay. Well, you can stop.